Okay, so tonight's discussion is going to be on translation, the second step of protein synthesis. And so what I've got here is a picture of our ribosome. So as you remember from our discussion in class, this guy right here is what this mRNA strand right here. Let me get my pen. This mRNA strand is what has resulted from the first step, which is transcription. So this is heading out of the nucleus into the cytoplasm, and you can see here that this mRNA strand is now in the cytoplasm, and it will head for a ribosome. Also, as a quick reminder, two kinds of ribosomes. The first one is a free-floating ribosome, and that would be the type of ribosome that would result in a protein that's going to stay in the cell. And then there's also the ribosomes that are on the rough endoplasmic reticulum, the rough ER. Those proteins, or those ribosomes rather, will then export the protein out of the cell as an example of like a cellular communication. Okay, so real quick here then, here comes our mRNA. It will proceed to the ribosome. Remember, there are two parts of the ribosome, the upper part and the lower part. So here comes our mRNA right through the middle of the ribosome. And what this is showing is that these, again, a few vocab words here. Let me get a different color. Codon. Again, my writing is very difficult on this laptop. So codon. So remember, the codon will be on the mRNA strand. They are groups of 3. So in this case, this would be a codon right here. This would be a codon right here. This would be a codon right here. And you guessed it, that is a codon right there. So we have 4 codons on this mRNA strand, and of course there could be, dozens more, 100 more, depending on how complex the code is for this protein. Now you'll notice here that this is going to be our tRNA. As you can see here, it's labeled. Get a different color. So here's our tRNA. You can see it's labeled right here. The tRNA will have 2 parts to it, an anticodon and this anticodon will simply be, much like the codon, a 3 base pair. So here they are. Anti, of course, means the antithesis or opposite of the codon. So don't forget, the codon is part of the mRNA. Anticodon will be part of the tRNA. And our tRNA will come on up into this ribosome, and you can see here that this one wouldn't have fit here because you've got to have the matching base pairs of the nitrogen bases. Again, remember, hydrogen bonds are going to connect these. They are going to chemically, purines and pyridamines will connect here. And you can see that it's a perfect match, G to C, G to C, U to A. So that T and RNA will fit perfectly right there. This anticodon will fit nicely with the codon. And what's going to happen is each tRNA, as we discussed in class, has an amino acid attached to it that's unique to that 3 base pair. That would be unique to that one. This would be unique to this one. These are already complete. So what you would simply have here is basically what it means by this growing protein here are these are amino acids that have been completed as it comes through. And these ones are already done. So once they're finished, the tRNA will disappear, and you're basically left with nothing but a bunch of amino acids. Here is our peptide bond. I'll just use P for peptide bond. And do not forget, please, that a peptide bond, I'll even put it in red, is simply a bond between 2 amino acids, and be more specific, between the amino group and the carboxyl group. COOH and the NH2. So even though I'm drawing a bunch of blocks, and you see here in the diagram these big old things, remember that chemically speaking, these are nothing more than a bunch of molecules that have ends that chemically fit. All right, and then so here's our peptide bond, amino acids, and as we proceed here, this is going to be a growing protein because proteins are made of amino acids. So what we have here is an amino acid, an amino acid, an amino acid with peptide bonds. Eventually, what's going to be is, I will finish this now, this is going to no longer be just a peptide bond when you get many, poly for many. The peptide bond becomes a polypeptide chain. And this polypeptide chain is what then becomes the protein. P for protein. And we are done. So again, a quick review. Ribosome, located in the cytoplasm, whether it's free-floating or attached to the rough ER. Again, the difference being the free-floating ribosome would be unique to a protein that's going to be made such that it stays in the cell. A protein, or the ribosome that would be attached to the rough ER, would be a protein that's made that would be exported out of the cell. mRNA comes through into the folds between the upper and lower part of the ribosome. As it's passing through, the codons, or 3 base pairs, are read by the ribosomal RNA, or rRNA of the ribosome. It is then attracted chemically to a 3 base anticodon triplet pair here, that in turn is brought into the ribosome by the tRNA, or transport RNA. They will chemically match up, again, purines to pyridamines via hydrogen bonds. They will latch up. As it continues to proceed across through the ribosome, the tRNAs are no longer needed, and really what was needed here are these amino acids that are coded again by these 3 base pairs that attach to these 3 base pairs. So again, what you get are simply the amino acids that remain. They are chemically attracted to each other because of the chemical attraction between the NH2 amino group and the carboxyl group, forming what we see here is a peptide bond. Several peptide bonds between several amino acids create a polypeptide chain. And as we discussed in class, proteins are indeed made of amino acids, these being the monomers, M for monomer. This whole guy here, polymers are made of monomers, so here's our polymer, represented by a polypeptide chain. And you get enough of these things, they will become a complex protein. And we are done. All right, so I'm going to go ahead and put this into our web page as an example. Don't forget to add a little text so I know that you can explain it in words, not just using the picture and talking your way through it. So that's it, and we will see you guys tomorrow.